everybody. My name is Jeffrey van Gogh, or Van Gogh, as we say here in the Netherlands.
And I'm John Pampuch, engineering manager for core systems, and I'm responsible for production languages at Google.
Yeah, and if you look at our job descriptions, they're pretty similar. We both need to grow Kotlin adoption and improve tooling for Kotlin. Of course, we're in very different orgs. I'm in Android, and John is in core. Now, luckily, this is not a large company, the left-hand side not knowing what the right-hand side is doing. We actually have very different requirements for our audience. I'm focused on Android with over 2.5 million developers adopting Kotlin. John is focused on Google, Google pushing Android Kotlin apps to over 2 billion devices and running on tens of thousands of machines in a data center. So today we'll give you two sets of history of us adopting Kotlin at scale. So I'll talk about Android, and then John will talk about Google as a whole.
Yeah. All right.
Yeah,
Thanks.
Thank you. So Grace gave you an overview of the history of... Is my mic still working? Yeah, OK. Grace gave you a high-level overview of how we adopted Kotlin in the history there. I will give you a bit more technical detail and some of the reasoning behind the decisions we made. And then John will do the same thing on Google's side. So as Grace mentioned, we adopted Kotlin early on. This started in 2014 with my coworker Yeet rewriting the Kotlin data binding compiler in Kotlin. And this was actually a great way to get started in Kotlin. It's a very isolated piece of code. It doesn't run on millions of Android devices. It's for developers. And so we got started early on. And then, as Grace mentioned, IntelliJ is the base for Android Studio. And so our team started seeing Kotlin code a lot more there in 2014. And so we liked it so much that we, from the individual contributors and the tech leads, we really started advocating with our senior management, saying, hey, we need to look at this Kotlin thing. And so the way we finally convinced them is like over the less busy holiday season in the end of 2016, we asked our directors and VPs, like, hey, can you spend some of this time playing with Kotlin? And so when we came back in the new year after the holidays, they were all convinced. They loved the language as well. And so that's when we started rethinking, how can we adopt Kotlin? And it's not a small feat, right? Like, it's a language owned by a different entity. It's relatively new. How do we make sure that we can adopt this and make sure that it ages well? So that's why we created the Kotlin Foundation together with JetBrains. Now, of course, like any open source foundation, there's a lot of work around governance. It's a nonprofit. You have to deal with bylaws, getting members. You have to deal with trademark and IP law. But the thing that we really wanted to make sure we got right is how do we evolve the language? And we saw some examples of other open source foundations, and we didn't all like it. We saw some open source foundations, and I won't name names, but some open source foundations had a lot of committees and subcommittees to design new language features. And it either meant that there was no progress made at all, because committees couldn't agree, or they came up with different features that didn't really work well together. And so we said, hey, that doesn't sound right. And some other open source organizations, they had a benevolent dictator, which wasn't great either, because then you would get new versions of a language that had many breaking changes, but looked beautiful. And so we wanted something hybrid, lightweight. And so what we finally came up with was that we have a lead language designer who is in charge of all new features. Currently, that's Roman, who you saw earlier in the keynote. And so that doesn't mean that they get to decide every feature, but they get the final word. So it's still very open source. People can contribute ideas, discuss, recommend improvements. But the final decision of how features are shaped and when they are launched is with Roman. At the same time, we want to make sure that the language doesn't break from version to version. So we have a language committee that is in charge of approving any breaking change or deprecation in the language. And so in the 6 years that we have had the foundation so far, we have reviewed over 150 of these proposals. Most of them are corner cases. There's like, hey, if you use these 4 features combined in the compiler and you do this very specific thing, there's undefined behavior in the compiler. But there have been some more complex ones as well. Out of these, most of them we approved. A bunch of them we actually said, hey, can we make some changes, either have a longer deprecation process with longer-term warning, improve the diagnostics, give more guidance, try to do automatic refactoring. And then there's a handful that we said, hey, these changes are too risky, we should probably not do them. But in all, that's how it worked really well. So as Grace mentioned, when we announced official Kotlin support for Android in 2017, that wasn't just a done deal. We had to do a lot more work to really make Android work on Android. First of all, we had to bundle Kotlin with Android Studio. This required a lot of work. Android Studio does get a lot of benefits from being based on IntelliJ, like auto-completion, debugging, and so on, just works. But we have a lot of Android-specific things as well, right? We have WYSIWYG tools that generate code. We have profilers that need to know about your call stacks. We have templates that are Android-specific. We have this static analysis tool called Android Lint that has over 200 checks that all worked on Java. And so we had to do a lot of engineering work to make these all work with Kotlin, add a lot of test cases. And so this was a really big engineering effort, but definitely worth it. Then, as Grace mentioned, we had to port all samples to Kotlin, make sure that they're not just a automatically translated tool. We want to make sure the samples are idiomatic in Kotlin. And this actually turned out to be a great way to review our ancient samples to see if they're still in line with our modern practices. Then we have a lot of APIs in Android, and we have reference docs for these on developer.android.com. They're all based on a tool that we wrote that was a very customized version of Javadoc. And so it was not really feasible to use that to generate Kotlin syntax in your reference docs. So we actually worked closely with JetBrains to build on top of KDoc and Docker, and completely rewrote how we did the developer.android.com reference side. Then on the runtime side, the VM that runs on Android is called Art. It has a lot of optimizations to make your code run as fast as possible on your mobile devices, including some optimizations around loops. And it turned out that the Java compiler and the Kotlin compiler actually generate slightly different code for that. They're both valid bytecode, but they're just different enough that our JIT optimizations didn't catch them anymore. So we actually had to make changes to the Android runtime to do proper optimizations for Kotlin. And then lastly, we had to do a lot of work around helping people get ramped up for Kotlin, right? We had the benefit of playing with Kotlin for several years. Most of you hadn't, so we heavily invested in code labs, videos, like we had YouTube videos explaining different syntax in Kotlin, and then we organized a bunch of interactive in-person events called Kotlin Everywhere. Then we switched to Kotlin First, and still our work was not done. As people started to build larger projects in Kotlin, we're starting to see some of these issues around performance, right? The projects were larger, auto-completion started to take longer, there were some occasional memory leaks, and similarly with the Kotlin DSL and Gradle, like we started to see some performance issues. So our team worked very closely with JetBrains and Gradle to find these performance issues. Then on the library side, people wanted to use Android libraries, but they also wanted to program idiomatic Kotlin code. So we built this set of libraries called KTX that provide extensions to the existing Android libraries that make your code look idiomatic in Kotlin. And then on Room is our object relation model tooling. We wanted to make sure that people can benefit things like coroutines in Room as well as nullness. So there was a huge engineering effort to rewrite the Room engine. Now you can actually make very easy calls to your database from Room with suspend functions, so it's really nice. Talking about coroutines, coroutines really work well for Android. Basically, everything you do in Android has to be asynchronous. You don't want to block the UI thread. And so for your networking calls, your database calls, coroutines really works well. Now, the one caveat is that Android apps can be suspended for a variety of reasons. And you want to make sure that your background tasks suspend with them. So we actually shipped a bunch of lifecycle libraries that make that super easy to do. You don't have to worry about things hanging in the middle. Then for tooling, we released Kotlin Symbol Processor, which is an alternative to Java annotation processors. There are a couple of reasons we did this. First of all, the fact that Java annotation processors work with Kotlin is pretty amazing. It does some crazy things underneath. It takes all your Kotlin sources, it runs enough of the compiler to generate Java stubs, then run that through Java compiler, and then feed the output from the annotation processor back into the Kotlin compiler. The downside of that, it has to do that round trip, but it also makes it much harder to do incremental compilation. So your performance issues around the build are even worse. With Kotlin Simple Processor, we're fixing that. Next to that, with Kotlin Simple Processor, we can now have these processors reason about source constructs in Kotlin that don't exist in Java, like properties, top-level functions, etc. And then finally, we wanted to make sure that this also works for multi-platform. Like when you're doing multi-platform apps, obviously you don't have Java on all of these target systems, and with Kotlin Simple Processing, you can do that on each of these targets. Then finally, around tooling, we have this whole program optimization tool called R8, and we did a lot of work there to make it work well for Kotlin. One example is that Kotlin, anytime you have a public method or function, it needs to insert checks called intrinsics to make sure that if you call that function from Java, that you're not breaking the nullness guarantees that Kotlin has. Now, if your app is all Kotlin, that's really wasted, right? So you have all these checks there that you're not using. And so in R8, we can actually detect these and just remove all these extra checks that are no longer needed. And then finally, Jetpack Compose, built from the ground up on Kotlin, where you can closely with JetBrains teams to integrate that in the compiler. And it really leverages every feature in the language you can think of, extension methods, coroutines, delegates, and provides a really Kotlin First experience. So we're still doing a lot of work on Kotlin, working together with JetBrains and JetBrains and Gradle. So the biggest thing that we're working on is we're helping JetBrains with the K2 or Kotlin 2.0 work. We're first working on compiler correctness and completeness. Like porting a compiler is a lot of work, and like it needs to be right before it can be performant. And then we're doing a lot of work to port related tools, so Kotlin Simple Processing, the Compose compiler plugin, and Android Studio. Android Studio is probably the largest consumer of the Kotlin compiler as an API. We have so many places where we do refactorings, inject types, live edits, uses the compiler to generate code on the fly. So a lot of work going on there. Then we're doing a lot of contributions to the Kotlin Gradle plugin. So as the Android Gradle plugin and the Kotlin Gradle plugin were built, they were shipped in separate release cycles. And so what ends up happening is they call into a lot of internal APIs from each other, which is not great. And so what we're working on with JetBrains is to formalize the API, set more strict boundaries so that we can ship updates out of bound while still not having to call into each other's internal APIs. Last, I mentioned Kotlin Simple Processing. Kotlin Simple Processing has been out for about 2 years now. The problem is that you'd only get the performance benefit of Kotlin Simple Processors where all your processors in your project are using KSP, so you don't have to pay that huge cost for Java annotation processors. So we're actually working with a lot of the big annotation processors to port to Kotlin Simple Processing. We've got Glide working, and now we're working on Dagger and Hilt, and that should really open up most people to be able to adapt Kotlin Simple Processing. And of course, we have to track compiler releases so that you don't have to deal with breaking changes. And then the last thing is we're adding tools in Android Studio that will tell you, hey, you're using this annotation processor, but they just released the Kotlin Simple Processor for this as well. Let me help you refactor your code, and you can get those performance benefits. In the Jetpack side, as Grace mentioned, all new libraries are written in Kotlin. We're also porting a bunch of the existing libraries to Kotlin, so we can get the modern code. We can consider making them available for multi-platform. And then lastly, I mentioned that Room supports things like suspend function. It's kind of crazy right now. For backwards compatibility reasons, it actually generates Java code, which is kind of bizarre-looking code because it has to express the way that the compiler would generate coroutines. So we actually generate Java sources that contain those patterns. And the team is now working on changing the code generation to Kotlin, which will be much cleaner, faster, etc. And lastly, with the whole effort around Compose, we're working hard on live edit. This is a Kotlin-only composed-focused effort to decrease your iteration cycle from edit, build, deploy. And it's really fast. Like you type something and it updates on your app immediately. Of course, we want to make sure it's correct first, and then we'll focus on the speed. And with that, sorry, one more thing. We're also doing a bunch of experiments around Kotlin Multiplatform. As Grace mentioned, we are contributing to several efforts there. So on the Kotlin native side, we have engineers contributing to the Kotlin native compiler. So we made improvements to the garbage collector. We also contributed a custom memory allocator. In performance benchmarks, we are seeing about 18% improvements on those, so that's quite promising. And then the thing that we're currently working on there is to reduce link time. In Kotlin native, the link step is really the most expensive part, and so any improvements we can make there really will help developer productivity. And then, as we said, we are reporting a couple of Jetpack libraries to be available on Kotlin Multiplatform. So those are collections, data binding, and annotations. And so they allow you to reshare that knowledge on multi-platform. Now, to facilitate that, we actually had to make contributions to the Kotlin Multiplatform Gradle plugin. The Jetpack code base is a mono repo, so all Jetpack libraries are built from one repo using Gradle. And we had to retrofit multi-platform to that. And so our Gradle experts made a bunch of contributions to the multi-platform plugin to make that work. So with that, I'll hand it over to John to talk about how we adopt Kotlin at Google. Thank you.
Thanks, Jeffrey. So before I start too deep into the slides, I do want to mention a little bit about what happened 5 years ago, or thereabouts, when the Android organization approached what's now called Core and said, you guys should get with the picture, get with the program and adopt Kotlin. And there's like, but we have processes and documents and policies, and all this stuff added up to being very resistant to Kotlin. And so a lot of what I'll be talking about today is how we overcame that resistance. Kotlin is a huge improvement for Google, but we don't make it easy to adopt a new language at Google. In fact, there are barriers in place. And so some of the things I'll be talking about are how we got through that. And as Jeffrey noted, we have similar responsibilities. And we are working together today much better than we did 5 years ago when, as I said, there was resistance. So before I start into Kotlin, though, I want to talk a little bit about Java. So Java is used very extensively at Google. A wide range of use cases. We have microservices that run, gRPC between processes, lots of business logic, Spanner, which is a database system effectively, and other database clients, server-side web applications. This is the primary use case for Java, is anything user-facing, generally I/O-bound rather than compute-bound. HTTP services, HTML templating, and just exposing Google to the outside world. And of course, we build Android apps that are parts of, some are distributed, I think, with Android, but certainly a lot of them get downloaded through the App Store. And they have platform native UIs, and we have multi-platform work. And a lot of that work is getting adapted to work well with Kotlin. And I would encourage people to go to Jason's talk, I think right after this one, to learn more about that. As I said, a wide variety of workloads. We also have workloads that are very different scale. As I said, microservices, yes, but also giant monoliths that are, stretch the limits of the JVM, of the compiler, of the build process, and so forth. And all of these things add up to making every little step with Kotlin to make people nervous. It's not that people disliked Kotlin. It's like, but can we do that? But we can. So again, in terms of how Java's used, first of all, as I said, very I/O bound. So we want a lot of non-blocking code. So allocated but inactive threads are expensive. Stacks are huge. So coroutines look very promising for us. We have long-running processes, days, weeks, months sometimes. So resource leaks can really be bad, and the JIT is great. We love the behavior of the JIT. Once things get warmed up, performance is amazing, and we're really happy with the results we get. We have what we consider to be very mature code. And I mean that both, some of it's very old, but also it's very stable, very reliable. We have libraries of all kinds that are used all over the place. We have tools like auto-value. We have policies like readability. If you're not familiar with readability, I'd encourage you to find out about it and look into how you might apply it in your use cases. We have an automatic formatter that takes Java code, and similarly for Kotlin, and puts it into the physical representation of Google style. This saves people a lot of work and eliminates a lot of bickering about how things should be laid out. We also have very mature tooling. We have code search. This allows engineers to search the code base for what they're looking for everywhere. Tools like ErrorProne provides a static analysis of Java code. We have build and dependency management and continuous integration using what we call Blaze, but you might know of as Bazel. And we have integration with both IntelliJ and an internal cloud-based IDE. All of this I'm pointing out because these are things that we, to a certain extent, need to replicate to make work well with Kotlin. We also have an enormous single repository of all the code that we run in production at Google. This can make updates hard. A new version of the compiler we're expected that everything just compile when that new version gets rolled out. And so, there's a team that's tracing down every compile error that occurs and working with Jeffrey's team to minimize those errors, but also fixing up people's code because maybe they didn't exactly know how to write something in a way that would be forwards compatible. Backwards compatible libraries are definitely a lot easier, but oftentimes people want to introduce non-backwards compatible things, and that becomes a bit of a headache for us. So that's a lot of work. We've got a lot of things to do. Why do we want to drive Kotlin into Google? Well, you've seen stats like this. I saw some with Grace's presentation and earlier Jeffrey, but 70% of developers that we work with are saying that when they use Kotlin, they are more productive than they are with other languages. It's faster to write. It's faster to review code. I think that's actually a big advantage. And debugging is also easier. The language features are really extraordinary. DSLs, the coroutines themselves, and how we apply them. Lewis did some work with DSLs to create a really amazing wrapper around protobufs. And these things really bring out the value of Kotlin. And strong coding paradigms like immutability just makes developers more productive. As a general rule, again, developers are satisfied. It's easy to ramp up. They can do it incrementally. This is a really big win for Kotlin. We don't have to just shift whole projects or whole teams or the whole repository. We can go start with a single source file and introduce Kotlin, and that works. It also means that people can learn it incrementally and adopt it at their own pace. We also noted earlier today that applications written in Kotlin are less likely to crash. Null safety being one factor, but just generally being able to write better code that's easier to reason about goes a long way. these advantages, are things we first saw in the Android space, but we certainly want them when we do server development as well. We also started some analysis, and we're going to repeat this, and I'll talk a little bit more about it later, but we didn't find a significant degradation in productivity for developers who were mixing Java and Kotlin code. And that was a big deal for us. That really drove a lot of our policy in terms of how we would adopt Kotlin. And then just a lot of developers using Kotlin in Android means that there's a lot of interest, and it gives us a lot of exposure so that developers can come in and be productive. One of the things we found that I find interesting is that we started getting interview candidates for roles at Google, where they were asking if they could write in Kotlin. They preferred that, and that was a gating factor for them coming into Google. That's all anecdotal, but I think that's a big win. So, add Kotlin to our build system, start writing Kotlin code, run in production. We're done, right? Not quite. It's all those other things I mentioned. We need, first of all, we got to GA, and there were a lot of steps to get there. And we have thousands of developers. Actually, no. Right now, we have 2,900 developers. That number just bumped over 2,900 yesterday, right in Kotlin. 11 million lines? No, actually, we now are at 15 million lines. These slides were originally presented in some form back at DevOps last year. And these are the changes we've seen since then. And we continue, continue to see year-over-year growth of about doubling Kotlin within Google. So, if you're a single developer, you can adopt Kotlin pretty easily. You don't, all the tooling and integration and infrastructure and work like that, it's not something that you have to have. And a lot of it you get kind of for free, integrated with IntelliJ, for example. But when you're an enterprise, especially the size of Google, with as many developers as we have, it gets a little bit more difficult. And I did want to check, how's our time doing? Great, okay. So what are the next steps? What do we need to do to get to Kotlin First, as Jeffrey had been talking about for Android? One, static analysis. We have a lot of guardrails that we use when we work with Java. We want to adapt that so that it works with Kotlin where it makes sense. Some of them are built into Kotlin, and that's great, but other ones may not be required in many cases, but at Google, we enforce certain rules. Things like checking return values. We encourage, and soon will require, developers to check return values from everything, except when there's exceptions. This is a good programming practice, and we have policies and tools to help enforce that. And we have several hundred like this that we use with Java, and probably a slightly smaller number that we'll use with Kotlin. KSP. Jeffrey talked about KSP work that's going on, working with Dagger and Hilt and so forth. Well, we use Dagger and Hilt a lot. We need to get support for that built into the build system at Google. Migration tooling. You don't have to shift everything, but if you want to shift, it would be better if we had better migration tooling. You could certainly work with the built-in migration tooling in IntelliJ already at Google, but we want to have tooling that people can use on a larger scale, and that's a big step for us for this year. We talked a little bit about multi-platform. already, and again, I'll recommend people visit Jason's talk. And then all of the libraries that I talked about for Java, we at least want to have an idiomatic representation for those libraries. It might be just some extension functions, or it might be rewriting the whole library. It will vary from library to library. And again, that's a focus that my team will take this year and work with the suppliers of those libraries across Google. Static analysis is a particular place that I think is really important to talk about. As I said, for Java, we use error-prone. And if you're interested in error-prone, there's a URL here that you can learn a lot about it. It is tightly coupled to Java, though. It's built into Java-C. So it doesn't work with Kotlin. But it is integrated with Java's tools, or with Google's tools. Sorry, I keep saying that. And we also use it to implement large-scale changes across all Java code. That's a really high value for us when we want to, say, change an API in a library like Guava. Guava is used extensively across Google. And if we decide that an API isn't as well designed as we'd like it to be, we can just do that. Now, that's aggravating for non-Google developers because we make changes to Guava, and now you have to deal with that. But we've kind of committed not to break things on people too much. But for internal libraries, that's a big win. So for Kotlin, we need an alternative, and we've been using Android Lint. And Android Lint is not just Android and not just Lint. It does a lot for us. But what's particularly important about it is that it works with both Java and Kotlin. So the static analysis that we migrate from error-prone into Android Lint now covers all of our code. And because Java and Kotlin are highly compatible, when we have API changes we want to make with large-scale changes, we can make them uniformly across both. It does have some downsides. It is computationally a little more expensive, mostly because it runs the second process. I think that will get better over time. We have a lot of work going on with the K2 compiler that I think will get benefit there. But again, at this point, it works very well for us. So what other challenges do we run into? Well, we have a lot of engineers. And it takes time to train engineers. It doesn't sound like much, a couple of weeks. Well, multiply that out, and that starts adding up to real money. And organizations that are doing development, that are creating products for Google, they're like, I don't want to give up my team for a couple of weeks to go learn Kotlin. This is where the incrementality of Kotlin becomes a big win for us. But we do recognize that there is a cost, and we work closely with other business units at Google to help them with their training process and give them a way of achieving this without overburdening their engineering team. There's also motivation. I've certainly had Java developers come up to me and say, well, sure, Kotlin's got all these cool features, but I've been a Java developer for 20 years now. I built my whole career on this. Why do I want to switch now? Usually, after the couple of days with it, people switch. They're like, oh, this is easy. I get it. The good news is that since the ecosystem is essentially the same, there's not a significant burden to using Kotlin, and you get big advantages there. And then we also have a challenge of awareness. A lot of people just aren't even aware of Kotlin, and we have been working very hard to grow visibility for Kotlin within Google. So we do need to continue building out our ecosystem, tooling, documentation, working on best practices with our readability program, and a support team. Both of those are interesting challenges. The growth of Kotlin is so fast. Oh, I can see I have 10 minutes left. That we run we can't keep up because we can't grow the readability program fast enough. And then we have some process choices, standards, how we do things. Do we write tests first in Kotlin, tests last? Do we need to develop a coding style, which is mostly underway at this point? And then I did want to quickly talk about mixed code. So we did an internal study years ago comparing pure Java applications to Java and C++ applications. And there was a significant burden to mixing Java and C++. And so one of the concerns everyone had is, hey, if we're going to mix Java and Kotlin and stuff, isn't that going to be a headache? Well, it turns out it isn't. Java and Kotlin play together so well that it is not a burden. Now, we do want to repeat this study, or analysis, really, because we want to make sure that we got it right the first time. But my speculation is that because the ecosystems are so similar, and the paradigms, and libraries, and memory models, and all the other aspects are close enough that the burdens that you would have with two diverse languages just don't exist. And so let's finish up with the outcomes.
Okay, so we've seen a lot of stuff we did to adopt Kotlin at Google and Android, but luckily it's not just applicable to us. Like the work that we're doing at Google hopefully benefits the whole community. So first of all, we do a lot of testing. Anytime we have a breaking change for language committee that we're uncertain about, we run a patched version of the compiler on all of Google's code and see what happens. And we have had a couple of times we're like, ooh, we didn't think about that scenario. Let's table this change. Similarly, like with the new compiler, K2, Compose, Android X, we test the new compiler on Google before it goes out. And then we also, Google has a big testing strategy. Like every code that's checked in needs to have tests. And so we're able to use the thread sanitizer and run that on coroutines and on all of Google's tests. And we actually find some issues in the coroutines library that you would easily find when you're manually running coroutines. And we actually helped contribute fixes to the coroutines libraries that way. You want to talk about open source contributions?
Not really.
Okay, I'll take that. So we made a lot of open source contributions. So I mentioned earlier Dhaka, it's the documentation tool. Google has made another contributions to that as we built out our reference guide on android.com. Then we built protobuf and gRPC wrappers, kind of like Kotlin extensions to make them idiomatic in Kotlin. Those are open source and anybody can use. And
I have to say, I use the protobuf examples as one of the quintessential examples of why Kotlin is better.
Yep.
It's just, it looks fabulous.
And then you heard Igor talk earlier about the new grants program. And so we actually have a couple of Google engineers participating, one here, Louis, in helping guide that committee and provide API design guidance. Then performance. So Android Studio is used by Googlers to develop Android apps. Google's applications are massive, and so we find performance issues early and help report them to JetBrains. And then we built this tool called JVM API Gen, which allows you to avoid recompilations if no public APIs change, and that's used now in both Blaze, Bazel, and Gradle. We do a lot of dogfooding. When the new backend for Kotlin compiler was being tested, we actually turned it on in Google 3 and shipped production Android apps before it went stable. And we're planning to do the same thing with Kotlin 2.0. And then, of course, you saw the experiment in Google Docs where we're using Kotlin Multiplatform and computing back there as well. Lastly, Google is a really big proving ground for Kotlin. We run Kotlin at a massive scale, either deploying apps to billions of Android users or running it on hundreds of thousands of machine and data centers. Or more. And those apps are large, right? Like it's very common for a Java app or JVM app on a server to have a class path that's larger than 2 GB. That's crazy. And then lastly, we have onboarded thousands of engineers, and they've all been very successful. So yeah, we definitely think Kotlin is the future, and we love contributing back to the community.
I do want to add on open source. You heard us talk about a lot of things that if we haven't open sourced already, it's our intent to. The reason why we haven't is because we just don't like dumping things over the wall. And so we need to figure out how we're going to support things long term before we open source something.
Absolutely. With that, I don't think we have time for Q&A right now because we're close.
5 minutes.
We can try to take a few questions here still, but John and I will both be at the Google booth later today, and then I'll also be on the closing panel tomorrow.
No, actually, I'll be at the booth tomorrow.
Yes.
And you'll be at the panel tomorrow.
Yes, absolutely. Yeah. So with that, if anybody has any questions, I think there's a mic somewhere there in the middle. There's the mics. Yep, that's the question here. Oh.
Hello, can you say something more about your cooperation with Kotlin team? How it works? Is it like a shared team, or how it looks in more details?
Yes, so we have many teams at Google working with many teams at JetBrains, and so there's not a single way that the team operates. I can talk about how my team, so I run the Kotlin compiler team at Google, so we have quite a few engineers working on the Kotlin codebase. So it's a variety of communication. We have bi-weekly status meetings, we have a Slack channel we chat, there's code reviews. Before the pandemic, there were regular in-person meetings, and luckily they're restarting. Like some of my teammates spent the whole day yesterday talking to engineers from JetBrains in the Google Amsterdam office. So yeah, we work super closely with JetBrains. I think we work closer with some folks at JetBrains than many engineers at Google, right?
Yeah, and we work not as closely with JetBrains as you do, but I know that Louis and Kevin Bierhoff, who leads the Kotlin team in my group, they're engaged, and we have I think a weekly engineering meeting with JetBrains engineers. We certainly are doing a lot in the Kotlin Foundation,
yep.
Where we collaborate. So I don't know if that answers the question, but we do collaborate a lot.
Well, and the thing I'd like to add is it's not just us doing drive-by code jumps. Like we actually work close together, and like some of our team's members at Google are now considered the expert of certain parts of the compiler, right? Like one of the guys on my team, he's the expert on UAST, and when JetBrains folk have a question, they come to him, and when they make a change there, they send him the code review.
There's
microphone is being brought.
I would like thank you for the talk. I think Google is doing a bunch of data science, and I wanted to know if you are currently or evaluating using Kotlin for data science at Google.
I'm sorry.
Asking about Kotlin for data science. So there was the demo at the keynote. I don't think we are the right people to ask about that.
Yeah, I mean, my team is not involved in that a lot. I will. What my team does is more focused on Python with data sciences, but I think that can change. We haven't gotten to that step yet.
Hey, regarding cross-platform development, what is the recommendation now that we have Flutter and we have KMM? So my company is in a crossroad, and we need to choose. So
that's a good question. I expected it to come up today. I mean, it really depends on your situation. They're both good solutions for specific problems. I mean, my team is experimenting with Kotlin Multiplatform, but I have coworkers on the Flutter team, and they integrate to IntelliJ, and we work closely together on IntelliJ questions. So it really depends what is the best solution. Like, are you building something that you want to use native parts of the UI? You want to have something that you don't care much about having each piece of the platform accessible and just want to develop really fast? They're all different trade-offs you have to make, and I don't think it's as easy as saying Flutter or Kotlin Multiplatform. It really depends on your situation.
And things like Jetpack Compose were modeled in many ways after Flutter, because Flutter is successful. It has a lot of nice properties. And I don't think we can, they're both good.
Okay,
great.
Looks like we're out of time.
Yep.
So yeah, find us at the booth or at the closing panel, and thanks so much for your time.